In the deepest, darkest parts of the ocean, where sunlight never reaches and the pressure would crush a submarine, there lives an animal with the largest brain on Earth, the sperm whale. It hunts giant squid in the freezing black, thousands of feet below the surface. And it talks. Not in songs, not in calls, but in rapid bursts of clicks, fired back and forth like a conversation in a language we have never understood. For decades, scientists recorded those clicks and wondered, were they just simple signals? Or was something far more complex hiding inside the noise? Recently, a team of researchers turned the full power of artificial intelligence onto thousands of those recordings. And what the machines found, hiding inside the whale's clicks, stunned even the people who have spent their lives studying them. Let me take you beneath the waves. First, you need to understand the animal. The sperm whale is one of the most extraordinary creatures on our planet. It has the largest brain of any species that has ever lived, a massive organ 5 times the size of a human's. It lives in tight, matriarchal families, with grandmothers leading the group and helping raise the young. It dives deeper and longer than almost any other mammal, hunting squid in the pitch-black depths. And it does all of this, coordinating hunts, raising children, caring for the injured, in near-total darkness. To live that life, it needs to communicate. And communicate it does. The sperm whale's social world is as rich and layered as our own. They live in matrilineal families, with grandmothers at the helm, passing down knowledge across generations. They take turns babysitting each other's calves. They even support each other during childbirth. And they organize themselves into vast clans, each with its own distinct culture, its own behaviors, and crucially, its own dialect. These dialects are not genetic. They are learned, passed from mother to child, the way human language is. 2 clans can share the same waters, hear each other's clicks every day, and yet choose to stick with their own patterns, their own way of speaking. It is, as one researcher noted, strikingly similar to what we see in human populations. Sperm whales produce sound by forcing air through an extraordinary organ in their heads called the spermaceti. Their clicks can reach 230 decibels, the loudest sound produced by any animal on Earth, louder than a rocket launch, powerful enough to stun prey. But the clicks are not just weapons. Many of them are social. When sperm whales gather near the surface, they press their enormous heads close together, and they exchange rapid sequences of clicks, short bursts of 3, 4, 5, up to 40 clicks, in patterns scientists call codas. For years, researchers assumed these codas were simple acoustic labels, basic identity tags, the equivalent of a name. They were wrong. In the year 2024, a team from MIT's Computer Science and Artificial Intelligence Laboratory, working with a project called CETI, the Cetacean Translation Initiative, published a study that changed everything. They had gathered an extraordinary dataset, nearly 9,000 codas, recorded over 13 years from a clan of about 400 sperm whales living in the Eastern Caribbean. The recordings captured the voices of roughly 60 individual whales. To gather this data, the researchers used special biometric tags, called D tags, which they attached suction cup style to the whales' bodies. These tags recorded not just the sounds the whales made, but their depth, their movement, and their orientation in the water, giving the scientists a complete picture of what each whale was doing at the exact moment it clicked. It was a window into their world that no one had ever had before. And instead of listening to them by hand, the researchers fed them into machine learning algorithms, pattern recognition systems that could detect structures no human ear could ever hope to hear. And the AI found something no one expected. The codas were not simple, fixed signals. They were built from a rich, combinatorial system. The researchers identified 4 separate features that the whales could mix and match. The first they called rhythm, the pattern of spacing between the clicks. The second was tempo, the overall speed of the entire coda. The third was the most surprising. They called it Rubato, after the musical term, because the whales would deliberately speed up or slow down during a coda, making sub-second adjustments to match the timing of the whale they were talking to, synchronizing their speech in real time. And the fourth was ornamentation, an extra click sometimes added to the end of a coda, like a flourish, which seemed to act as a kind of discourse marker, the way we might say, you know, or right, at the end of a sentence. By combining these 4 features, the AI identified 156 distinct codas, far more than the 21 that had been known before. And the whales did not use them randomly. They varied their calls depending on the context of the conversation, adjusting their rhythm, their tempo, and their ornaments based on who they were speaking to and what was happening around them. The system was, in the researchers' words, a combinatorial coding system, a sperm whale phonetic alphabet. And that is exactly what surprised the scientists. because this kind of combinatorial structure, where a small set of basic elements can be combined to create a vast, potentially infinite number of distinct signals, is one of the foundational features of human language. Linguists call it duality of patterning. It is the reason we can take a few dozen meaningless sounds, phonemes, and combine them into every word in every language on Earth. And now, it appeared, sperm whales might be doing something remarkably similar. As the lead researcher put it, once you have a combinatorial basis, you can take a finite set of symbols and compose them to create an infinite number of meanings. These were not just clicks. They were, potentially, the building blocks of a language. But here's where the honesty matters, and where the story gets more complicated. Because as remarkable as this discovery is, the scientists are quick to stress what they have not done. They have not translated the whales. They have not decoded the meaning of a single coda. What they have found is structure, the architecture of the communication system. They know the whales are combining elements in complex ways, but they do not yet know what those combinations mean. It is as if you had discovered the alphabet of a foreign language and the rules for how its letters combine, but you still could not read a single word. The meaning remains locked away behind the clicks. And that gap between structure and meaning, between knowing the how and knowing the what, is the frontier the researchers now face. Every coda they have identified is a question mark, a word in a dictionary with no definitions attached. They know the whales are saying something rich, something structured, something that matters enough to be passed down across generations. They simply do not yet know what it is. And not every expert is convinced by the phonetic alphabet framing. One leading marine mammal researcher, Luc Rendell of the University of St. Andrews, pushed back on the comparison, arguing that the way whales use tempo variation is completely different from how we use an alphabet to construct language. He was skeptical, too, of the ornamentation clicks, suggesting they might simply be production glitches, the equivalent of a human saying or There is a real, ongoing scientific debate about whether to call this a language, a phonetic alphabet, or something else entirely, perhaps closer to music. Some researchers believe the codas may function less like words and more like songs, communicating emotional states, social bonds, and group identity without carrying specific, word-like information. And yet, even the skeptics agree on one thing. The sperm whale communication system is far more complex than anyone imagined. Whether it is language, music, or something we do not yet have a word for, it is a system of communication built from structured, combinable elements, used socially, varied by context, and learned and passed down through generations. Different clans of sperm whales, it turns out, have entirely different dialects, distinct coda repertoires that are socially learned, not genetically inherited. A recent study even found that sperm whales in the eastern Mediterranean have developed a different regional dialect from those in the West, the same way human languages drift and split over distance and time. The cultural history of the sea, it turns out, does not belong to humans alone. What makes this so profound is the parallel the researchers themselves drew. One of them described the work as being like trying to communicate with an alien civilization. Here is a species with the largest brain on Earth, living in a completely different environment, with a communication system that evolved entirely independently of our own, over tens of millions of years. And we are only now, for the first time, beginning to glimpse the architecture of how they talk. If we can learn to understand them, it would not just be a scientific breakthrough. It would be the first time in history that humans successfully decoded the communication of another intelligent species. And the stakes go beyond science. Sperm whales are still recovering from centuries of hunting. They face ship strikes, entanglement in fishing gear, and the growing noise of human industry drowning out their voices. If we can prove that these animals have distinct cultures, dialects, and structured communication systems, it could transform how we protect them. Understanding what they say to each other could help us design quieter shipping lanes, better sanctuaries, and conservation programs that respect not just their bodies, but their minds. The researchers behind Project CETI have an even bolder ambition. Their next step is to try to link specific codas to specific behaviors. If they can determine, for instance, that a particular pattern of clicks is used when the whales are coordinating a hunt, or warning each other of danger, or greeting a new calf, they will move from understanding the structure of whale communication to understanding its function. And from there, perhaps, to its meaning. They are building AI models that can predict what a whale will click next, and they dream of a day when we might be able to talk back. We are not there yet. But for the first time in human history, it no longer seems impossible. So here's the question I want to leave you with. If sperm whales have a structured communication system as complex as our own, do we have a responsibility to learn what they are saying before their voices disappear forever? I want to hear your answer. Drop it in the comments below. If this dive into the minds of whales captivated you, share it with someone who loves the ocean. And subscribe, because the next secret we uncover from the deep might be the one that changes how you see every living thing on this planet. Until next time, listen to the ocean, respect the minds within it, and never assume that intelligence belongs to humans alone. I am Arif Hassan, and this is AH History.